In just days, an alien visitor from the depths of the Milky Way, 3I Atlas, will sweep past Mars at a blistering 130,000 miles per hour, flaunting chemistry unlike any comet ever seen. But as it races toward the Sun, this rare interstellar object is about to vanish. Earth's most powerful telescopes will lose it for 30 days, precisely when it transforms in the searing heat of perihelion. Why does the moment of greatest change happen completely out of sight? What secrets could Mars orbiters catch as the world goes blind? And what will emerge when 3 Atlas returns? This is the story behind 3 Atlas will disappear for 30 days. Here's what happens next. On July 1st, 2025, astronomers caught sight of something that didn't fit any familiar pattern. A small active object streaking through the inner solar system with a velocity of 130,000 miles per hour. The designation 3 Atlas came quickly, but nothing about this visitor was routine. Its path curves not in the gentle ellipse of a solar system comet, but in a wild hyperbola, an escape trajectory, proof it was born far outside our sun's influence. Calculations traced its origin to the thick disk of the Milky Way, a region populated by stars that formed more than 7 billion years ago. The chemistry is just as alien. James Webb Space Telescope spectra show a carbon dioxide to water ratio of 8:1, the highest ever measured in a comet. Most solar system comets are dominated by water ice, but 3 Atlas is different. Its volatile mix hints at a birthplace under conditions no local object has experienced. The nucleus, likely less than 6 kilometers across, is already shedding gas and dust, building a coma that flashes with sunlight as it closes in. Every kilometer it travels is a new data point in the story of planetary systems beyond our own. And now, with a close pass by Mars just days away, the urgency to capture every possible detail has never been greater. On October 3rd, 3 Atlas will make its closest approach to Mars, passing at a distance of 28 million kilometers, a span that puts it nearly 200 times farther than the famous Siding Spring comet flyby. In 2014, for mission teams at ESA, this is the last clear window before the comet disappears behind the Sun. Mars Express and the ExoMars Trace Gas Orbiter are set to train their instruments on this interstellar traveler. The HRSC camera on Mars Express, designed for mapping the Martian surface, will be pushed to its limits, trying to resolve a nucleus likely less than 6 kilometers wide from a distance where even the largest comets become faint points of light. Kesson TGO, with its longer focal length, will attempt to capture the expanding coma and any hints of jet activity. Spectrometers like Nomad and Omega will scan for signatures of carbon dioxide and water vapor, chasing chemical clues that have already set 3 Atlas apart from any comet seen before. The challenge is steep at this range. The comet's signal will be a whisper against the cosmic background, and even the most sensitive instruments may struggle to pick it out. But for scientists, every bit of data counts. This is the last shot. At a close-up before 3 Atlas slips into a month-long blackout, and the clock is ticking. Solar conjunction begins as a matter of pure geometry, as 3 Atlas sweeps past Mars and closes in on the Sun. Its position in the sky draws nearer and nearer to the solar disk from Earth's point of view. By the first week of October, the angular separation, what astronomers call solar elongation, drops below 30. Most ground-based telescopes simply cannot observe anything that close to the Sun. The risk of scattered sunlight swamping sensitive detectors or even damaging them is just great. By October 6th, even the Vera Rubin Observatory and other wide-field surveys are forced to stand down, their safety protocols triggered by the shrinking angle. The blackout will last until early November, a span of about 30 days when no Earth-based telescope, no matter how advanced, can track the comet. The window closes just as 3 Atlas is expected to reach its peak activity, closest to the Sun, hottest and most dynamic, yet completely hidden by solar glare. The blackout is not just a technical inconvenience. It is a direct result of the orbital dance between Earth, Sun, and comet, locking the story in a month-long observational void at perihelion. 3-2 Atlas enters a trial by fire. On October 29th, it will sweep past the Sun at 1.36 astronomical units, racing along at 70 kilometers per second in this crucible. Sunlight strikes the nucleus with more than twice the intensity it experienced at discovery. The surface, already venting carbon dioxide jets at 129 kilograms per second, faces a surge of thermal stress that few comets survive unchanged. Models predict the outer layers will bake, driving outgassing to its peak and pushing the fragile crust toward its breaking point. Water ice buried just beneath the surface could sublime it with enough force to shatter weak spots. In the nucleus, the risk of fragmentation looms large. No one can say if the core will hold together or split apart as hidden faults are tested during this 30-day blackout. The comet's fate is sealed in silence. When 3I/Atlas reappears, scientists will scour every detail for signs of cracks, lost mass, or new jets, searching for evidence of what happened in the sun's unblinking glare. In early November, telescopes around the world turned back to the sky, searching for the first glimmer of 3I/Atlas after its long silence behind the sun. Within days, the first images begin to trickle in, faint but unmistakable. Astronomers quickly compare the new brightness to pre-conjunction predictions. Has the comet faded or grown unexpectedly bright? Early measurements show a coma that appears slightly expanded with hints of new jets streaming from the nucleus. The tail, shaped by weeks of solar heating, now stretches farther and shows subtle changes in direction, a record of outgassing events that played out unseen. Teams scan for fragments or sudden gaps in the dust, searching for signs that the nucleus survived its trial by fire intact. Each new data point is logged, building a timeline of the comet's recovery as it moves toward its December encounter with Earth. The story of 3I/Atlas resumes, changed, but not finished. On December 19th, telescopes across 6 continents will turn toward a patch of sky as 3I/Atlas makes its closest approach to Earth, passing at 1.8 astronomical units. This is the last best chance to capture the full story of an interstellar visitor before it slips away for good. The global network of observatories, professional and amateur alike, will synchronize their efforts, pulling data in real time. Instruments will chase the faintest variations in brightness, hunting for fragments that might have separated during the comet's hidden trial by fire near the sun. Spectrographs will probe the chemistry of the coma, searching for changes in carbon dioxide, water, and carbon monoxide since the comet's emergence from conjunction. Each exposure adds to a record that stretches from the first detection in July to this final flyby. For many, the hope is to catch one more outburst, a last surge of activity as 3I/Atlas recedes into darkness. The December encounter is not just another observation. It's the closing chapter in a campaign that has tested the limits of what we can learn from a single interstellar wanderer. Every photon collected now will help answer the questions that began with a distant, unremarkable dot and grew into a global effort to decode the secrets of another star's ancient debris. On October 3, 2025, 3I/Atlas will pass just 28 million kilometers from Mars, a trajectory captured by ESA's Mars Express and Trace gas orbiter. For the next 30 days, ground-based telescopes on Earth will lose sight of this interstellar visitor as it moves within 30 of the Sun, reaching perihelion on October 29th at a distance of 136 astronomical units. This blackout coincides with the period of greatest activity, peak outgassing, elevated speed up to 70 kilometers per second, and potential fragmentation, all hidden from direct view. Mars orbiter teams hope their data will clarify the comet's unusual carbon dioxide to water ratio and origins in the thick disk of the Milky Way. But many questions about its structure and survival remain. When 3I/Atlas reappears in early November, astronomers worldwide will compare new images and spectra to pre-blackout data. searching for signs of transformation. The final Earth approach on December 19th at 1.8 astronomical units will mark the last opportunity for observation as of today. The fate of 3I Atlas during its unseen trial remains unknown, but every documented measurement brings us closer to understanding the nature of interstellar visitors.